Last meeting, we discussed the first example for a topic moment. Today is just a continuation of our problem solving. Once again, this is our answer for number 1, as you can see here. Let's move on to number 2. Okay. Number 2, in the figure, compute the moment of force F equals 200 kilograms and force P 165 kilograms about points A, B, C, and D. Okay. So once again, basically, we're looking for 8 answers here. Moment of force F about ABCD, and then moment of force P about ABCD. Looking at the matrix, each side is equal to 0.3 meters. So that is our basis for our distances for our equation for moment. Okay, let's begin. Okay, first, let's try writing our given. Once again, F is equal to 200 kilograms, and then P is equal to 165 kilograms. Okay. So let's try to analyze how to solve for this. So basically, we're just looking for a moment about certain points. And I've already taught you how to solve for that. It's using the equation m for moment equals force times distance. So if you know the perpendicular distance, it's easy to find out the moment. So let's check. Let's start with force F, and then let's take the moment of force F about A. So this is your point A. This is the perpendicular distance, which is somehow tedious to solve for. So once again, we're going to use Barron's theorem, wherein we separate F into its x and y components. Same thing with P. Okay, if we try to take moment of P about, let's say, point C, once again, we need its perpendicular distance, which is a bit harder to solve for because all we're given are the x and y distances from this matrix. So once again, we're using Barron's theorem. So that means we need to get the x and y components of our force F and P. So let's start with that. Let's start with the force F, so Fx, right? So to get Fx, the components, you either need an angle or a slope. Since we're given distances, most likely this is figuring out the slope. Okay, so let's take force F. As you can see, it starts at this point and then ends at this point. Okay, and then it creates a right triangle. From that, we can figure out its slope. Just count the number of sides. Okay, so let's see here. The base is 1, 2, 3, 4. So 4 units for its base, and then its height is 1, 2, 3. 3 units as its height. You don't have to write out or multiply it by 0.3 since this is just a ratio. Okay, if you simplify things, you'll still get 4 base and 3 height. So let's note that out. 4 base, 3 height. And then let's draw its slope once again. 4 base, 3 height, and we have another right triangle 3, 4, and we already know the hypotenuse of a right triangle with 3 and 4 sides is 5. So I don't need to solve for that. Or if you want, you can still use the step square root of 3 squared plus 4 squared. But by now, you should memorize square root of 3, 4 sides is 5. Or I mean, the hypotenuse is 5. Okay, now that I know the slope, we can now solve for Fx. So equation for x component is just copy the force F. So that is 200. Okay, I'm not multiplying this by gravity to get weight because it was not specified in our problem that we need the unit Newton. Okay, so that's why I'm still using the unit kilograms. So sustaining that 200, get the x component. X component, therefore we need the horizontal side. So that's 4 times 4 over hypotenuse 5. Please compute what's the answer. 160, correct. So that's Kurt and Emma de la Cruz Santones. 160. Do the same for the others. This is kilogram. FY. So same thing, copying the force, 200. Wala pa. Hindi pa ako nagtatanong. Hintayin niyo ako magtanong. So y component, therefore taking the vertical side 3. Please compute what's Fy. Correct, Lorraine and Lauren. So Chua and Rivera. Okay, it's 120. And then I'm gonna solve for P. Okay, so it's just the same process. So now P, finding out its slope. Right. Once again, counting. We have a right triangle. Base is 2 units, height is 3 units. So drawing that, this is 2, this is 3, and then computing for the hypotenuse, that is square root of 13. Okay, once again, you don't have to solve, I'll give you the answer. Px, so that's just copying the force, 165 multiplied by the horizontal side, which is 2, over hypotenuse square root of 13. And that should give you 91.53. Okay, you can solve along because you need to store this. Store this for easier retrieval when computing our answers. And same with Py. Once again, you may solve with me so that you can store this value. So it's 165 times, this is vertical, so that's 3 over hypotenuse square root of 13. If you compute for that, you should get 137.20. Yes. And then please store this value for easier retrieval. All right, now that we have our components, we can start solving for the actual moment. Now you can start with either F or force P. Let's try starting with F. And then we'll just take our moments. Let's start with A. Let's do this alphabetically, so A, B, C, D. Once again, starting with A. Moment about A, we're using Varanon's theorem. So that's just Fx times perpendicular distance plus Fy times perpendicular distance, depending on if it's clockwise or counterclockwise. We also learned a new concept as well last meeting, that it is easier to place your component at a point where it's easier to compute for the moment. So that means you're placing it at a point wherein one of the x and y components passes through the point so that it cancels out. So moment about A, I'm going to place my component here. Okay? Why? Because the x component will then pass through point A. Let me just move it so that I have space. Once again, I'm going to place my x and y components at this point. So this is your fx and fy. Remember, you can place your components anywhere along its line of action. I place it here because fx passes through A. So that means I can just ignore that. Right? So we're left with fy. Now check if fy is clockwise or counterclockwise. Rotate it about A. As you can see, that's counterclockwise. So that's negative fy. Then take the, or compute for the perpendicular distance. This is the perpendicular distance, so just count the sides as 1, 2, 3, 4, 5 sides. So times 5. And remember, each side is 0.3 meters. So 0.3 times 5. Fy is 120. Please compute what's the answer for MA. Remember, sign is important, so please include sign in your answer. So correct, Lloyd and Ricky or Colin. So Sosa and Terry. Okay. So it's negative 180 because we have a negative here. So negative 180. And then to get the unit of a moment, that's just the force multiplied by the unit of distance. So that's kilogram. Unit of distance is meter. So kilogram, meter. Okay? That's our first answer. Do the same thing for the others. MB. Let's check. This is point B. So I'm still going to retain the position of my components there because now Fy passes through B. So since Fy passes through B, I'm going to ignore that. So now we're left with Fx. So check Fx. This is clockwise. Therefore, positive Fx times 0.3. Then how many sides? Just count that. Okay. So that was 1, 2, 3, 4, 5, 6 sides. So times 6, please solve, knowing that Fx is 160. What's the answer? It's 288, correct. Positive 288. Correct, Kurt and Michelle. So Leon and the Cruz. It's 288. Once again, unit, kilogram, meter. Okay. Next, MC. This is point C. So therefore, for one of my components to cancel out, I'll place the component here. Okay? Remember, when drawing your components, it should be consistent with the actual direction of your force. So this is Fx, this is Fy. And as you can see, Fx passes through C, so I'm just going to ignore that, and now we're left with Fy. Rotate Fy about C, that's clockwise, so positive. Fy, then count the distance. It's this, so that's 1, 2, 3, 4, 5 times 5. Please compute what's the answer, knowing that Fy is 120. Right, it's 180. Correct, Rafael and Michelle, Tabug and Leon. Yeah, 180. So 180 positive kilogram meter. And then lastly, we have MD. Now check. This is your point B. There isn't a position where you can easily compute for the moment. Why? If I extend this line of action, and let's say I put the component there, we can do that because then you have to figure out this distance because it's not directly on a point or on an intersection of the matrix. There's this small distance above that. Okay, so it's not advisable to do that. Instead, you can just keep it wherever and just compute for both of the forces or both of the components. Okay, so I'm just gonna keep my component at this point. Okay, so let's start with Fx. Fx, rotate it about d. That's positive since clockwise. So positive fx multiplied by 0.3 and then count the sides. Extend this line of action. This is the perpendicular distance to d, and that's 3 sides, 3 boxes. Then we're not done. We still have an fy. So we're not done. Fy, rotate that about d. Now that's counterclockwise. So we have a negative fy times 0.3. Perpendicular distance, extend line of action, that's just 1. So please compute what's the answer. Correct, it's 108. So correct, Rafael and Marilyn Biliosis. And 108 kilogram meter positive. Okay, so you don't really have to find point where one of your components cancel out. You can just solve it naturally. Not naturally, but plainly, wherein you take both components. Okay, so that's still allowed. We're done with F. Let's move on to force P. So same thing with force P. Let's start with MA. Let's check force P. Is there a point where I can have A to cancel out? Well, for now, let's say you can't see it. Some of you might have seen it, the answer to MA using force P, but let's say we haven't figured it out yet. Okay. So technically, I don't know where to put my force so that, or my component so that one component cancels out. So instead, I'll just put it here. You can put it anywhere. Let's try putting it here. So this is my px, this is my py. Okay, so let's begin. Neither of these components pass through A, so I'll just solve for both. Let's start with px, rotate it about A. That's counterclockwise, so negative px. And remember, you stored your value for px and py. So negative px times 0.3 and then count the number of sides. Extend this px, so that's 3 boxes. Next, py, rotate py about A, that's clockwise, right? Yeah. So positive py, and 0.3, and then compute for the perpendicular distance. This is your py. Okay. Extend line of action, that's 2. So please solve what is MA. Correct. Francisco and Colin, Legado, Perry, that's 0. So what does that mean? Yeah. You should get 0. Now, why is it 0? Because if you try to extend the line of action of force P itself, you'll see that this actually passes through point A. Remember, any force, yes, correct, Zaira, point A is on the line of action, force P. Very good. That's why force about A is 0, or moment about A is 0, because any force that passes through your moment center creates a moment of 0 or creates 0 moment. Yeah, okay? So if ever you can visualize it, you don't even have to solve for moment at A from point P, because you can already see it passes through A. Automatically, MA0. Okay, so that's MA. Let's move on to MB. MB. Okay, so this is my point B. So I'm gonna put my component here just to make my equation shorter because as you can see, Px passes through B. So I'm gonna ignore Px now and then just use Py. Rotate that about B, that's counterclockwise. So negative Py, 0.3. How many sides? That's just 1. So times 1. Please compute what's the answer. Correct, it's negative 41.19. Don't forget the negative sign. Correct, Marilyn and Francisco. So peliosis, we got peliosis, a len, and then we got legs. Negative 41.19. Unit is kilogram meter. Then MC, where is C? Here. Okay, so that's my point C. I can just use this component here because Px passes through C. So I'm gonna ignore Px, we're left with Py, rotate that about C. Once again, that's counterclockwise. So negative Py times 0.3. How many sides? Count 1, 2, 3, 4. So times 4. Please solve. What's the answer? Correct. It's negative 164.75. Correct, Nicolas and Matthew. So Tanilon. Well, Nicolas. Well, once again, negative 164.75. Don't forget the unit, kilogram meter. And then lastly, MD. Where's D? Here. So I'm just gonna use the components here because Px passes through D. So I'm gonna ignore Px, we're left with Py, rotate that about D, that's clockwise, therefore positive. Py times 0.3, count the distance. This Py, this is the perpendicular distance, 1, 2, 3, 4, times 4. Please solve, what's the answer? Correct, Zyra and Matthew. So for this and it's positive 164.75. Positive 164.75 kilogram meter. And that ends our solution for problem number 2. Okay. Any questions for number 2? Please answer in the chat. Okay, great. Let's move on to number 3. Number 3. Two forces, P and Q, pass through a point A, which is 4 meters to the right of and 3 meters above a moment center O. Force P is 890 newtons directed up to the right at 30 degrees with the horizontal, and then force Q is 445 newton directed up to the left at 60 degrees with the horizontal. Determine the moment of the resultant of these two forces with respect to O. All right. So basically, we're given the description of your system of forces. You're supposed to draw that based on the description, but we already have the drawing here on the right. So let's check. So we have a point O. Force P and Q are 4 meters to the right. So 4 meters to the right, and then 3 meters above O. So 3 meters above. So this is where your P and Q are. Okay. And then force P is directed up to the right. So up to the right, that's this arrow right here. And it's 890 newtons with an angle of 30 degrees with the horizontal. Okay. And then Q is up to the left. So up to the left. So that's the direction of Q. It's 445 newtons and it's 60 degrees with the horizontal. Okay. So that's how you draw your system of forces based on description alone. Now our goal is to find the moment of the resultant of these two with respect to O. So there's two ways to solve for this. Okay. One is to solve for the resultant. We already know how to solve for the resultant of a system of concurrent force. The resultant of a concurrent force system by methods shown previously. But if you want to skip through that, there's another method wherein we just need to get, or we have to solve for the moment individually of forces P and Q. Let's do method number 2 so that I don't have to solve for the resultant anymore. Okay. So that means I'm directly solving for moments about O. So to do that, we're just going to get the algebraic sum of the moment of P and Q about O. So we can use the equation force times distance. Okay, however, if we extend the line of action of P, this is the perpendicular distance to O. And once again, that's a bit tedious to solve for. Same with Q, extending line of action of Q, right? This is its perpendicular distance. So it's a bit tedious again to solve for. So once again, we're going to use Varinon's theorem, wherein we use components x and y. As you can see, px and py are already drawn as shown. So now let's solve for it and place it in our equation. Let's start with px. Okay, so px, we can just write px, rotate it about O. That's clockwise. So positive px, px, then multiply it by its perpendicular distance. It's this length to O, and that is equal to 3. So multiply this by 3. Next, let's use py. This is py, rotate it about O. That's counterclockwise. So minus py. Once again, extend its line of action, and then this is the perpendicular distance equal to 4. So times 4. Next, let's move on to qx. Qx, this is qx, rotated about O. That's once again counterclockwise. So negative qx. Perpendicular distance, extending line of action, that's equal to 3. So times 3. And then lastly, qy, this is your qy, rotated about O again. That's once again counterclockwise. Qy, perpendicular distance, extending this line of action, that's 4. We delete that line. Okay, so now I have to get an equation for px, py, qx, qy. Let's start with px. Px is easy. We're given angles. Remember the equation for x component, given angle, that's f cosine theta. And then y component is f sine theta. So px, that's cosine. P is equal to 890. 890 cosine 30 is 3. Okay? Do the same thing for the others. Next, py, that's 890. Sine 30 times 4. Next, minus qx. Qx, okay? So cosine, angle, cosine 60. So q is 445. So minus 445 cosine 60. And then finally, let me just move this, create space. Finally, minus 445 qy. So that's sine. Forgot to multiply this by 3. Don't forget to multiply by the distance. We need more space. And then minus qy is 445 sine 60. Wait lang. Times 4. Times 4. Please compute. What's the answer? Okay, correct. It's negative 1676.74. Correct. Lloyd, and once again, unit is important. So Colin, I think you're already 2 points, right? So Rafael, Kasagi, and Sosa. Sosa, Kasagi. Once again, negative 1676.74. What's the unit? It's the unit of your force multiplied by the unit of direction. Force is Newton, direction is meter. So Newton meter. So this negative, once again, does not denote incorrect assumption. We didn't assume anything. We directly solved for a value. So this negative direction indicates direction. So negative moment means that's counterclockwise. So you can write your answer this way. Or positive 1676.74 Newton meter, and then you can just write counterclockwise, or you can just draw the symbol for counterclockwise. Okay. So for example, if the problem is asking for the direction of your moment, negative means counterclockwise. Likewise, positive means clockwise. Okay. So that's number 3. Any questions for number 3? Please answer in the chat. Okay, good. No questions. Let's move on to the next, which is number 4. Okay, number 4. Right. By the way, if you want to practice, one thing you can do is resolve number 3, but instead of doing what I did, you can solve for the resultant first, and then get the x and y components of your resultant, and then take the moment about 0.0, like what I did here. Okay, if you want to practice, do that. Okay, number 4. Without computing the magnitude of the resultant, compute where the resultant of the forces shown in the figure intersects the x and y axis. Okay, we're given a restriction. We're not allowed to solve for our resultant. And then we're just looking for x and y intersects. How do we do that? We've solved for something similar before, right? We're looking for the x and y intercept. So let me draw what that looks like first. So technically, you want to solve for r, okay? Because that r will indicate where your force will intersect your x and y axis. But we can't do that. However, we can still illustrate that. We can take a guess at where your R is. So let's take a guess. Two of my forces are to the right, so most likely my resultant is also to the right. The upward force, 500 pounds, is greater than the downward force, 361 pounds. So most likely, once again, resultant is more upwards. So it's upwards to the right. Try to draw that. Let's try drawing. Okay, so this is R. That's the position of your resultant. A sketch of the resultant. You don't have to be quite accurate here since our solution is analytical, not graphical. Okay, so as you can see, this is where your resultant intersects the y-axis, so we call that IY. Okay, you can call it y as well. This is just naming a variable. So I like to call it IY because it's intersect I. Next, let's extend your x-axis. Okay, this is the intersection of your x-axis, and then this is your I. This is where your force intersects the x-axis, and that's your IX. Okay, IX. Once again, IX this line. Oops. Now, how do we solve for that? Let's look at how we solved for the previous problem involving intersection. Okay, so let's look here. This is how we solve for the intercept. What we did is we place our component along the x-axis to solve for the x-intercept. Okay, and then we use moment to solve for that. So our solution for the other problem will be somewhat the same. So basically, we're gonna put the components of our force along the axis, of which the intercept is what we're solving for. And then we're gonna use the concept of moment. Okay? So let's say, this is your R. Component of R would be here. If I place it here, this is your Rx. This is your Ry. Right? And then, considering my components here, and then let's say I take moment about O. Okay, this is O. Rx passes through that. So I'm left with Ry. So as long as I know Ry and moment about O, Ry's perpendicular distance to O is Ix. So I can solve for Ix that way. Same thing with here, solving for Iy. I'm gonna put the components here. So this is Rx, this is Ry. Once again, I'm gonna take moment about O. Ry passes through O. So if I use an equation for moment, perpendicular distance of Rx to point O is this distance Iy. Once again, that's how I'm gonna solve for Iy. So what I need is Rx, Ry, and moment about O. So let's solve for each. Let's start with Rx. Rx is just the x component of the resultant. We're not technically solving for the resultant. We're solving for its component. So that's allowed within the restriction of our problem. Okay? So the only restriction here is I'm not supposed to solve for the resultant. Okay. So Rx is just a summation of the x component of our forces. Right? Summation of forces. So let's begin. Let's start with this 500-pound force. Sign convention, 500 to the right, therefore positive 500. We're not given an angle, we're given, again, a matrix, so most likely we're solving for its slope. So to get the slope, like what I did earlier, you have a right triangle, base 3 units, height 3 units as well. So if you draw that, okay, this is 3, square root of that, hypotenuse of that is square root of 18. Let's try doing the same thing for the 361-pound force. Base is 3, height is 2. So 2, 3, compute for the hypotenuse, that's square root of 13. Okay, now we have our slope. We can get the x component. So this is x component, so I need the horizontal, which is 3. So times 3 over hypotenuse square root of 18. Next, get the x component of the 361-pound force. To the right, so positive. So plus 361 times. This is x component, so I need the horizontal, so that's 3 over, this is 18, over square root of 13. Please solve. What's the answer? 653.92. Correct. Sino na una? Correct, Simon and Michelle. So, Leong, Che. Take two kami. Who else? Rafaela. So, pangalanan. L. 653.92. Once again, store the whole value of that for easier retrieval. When I say store, I don't mean store directly 653.92. I mean store the answer that you got. Because there's other decimal places here, right? You're gonna store the whole value. So 92354, etc. Okay, do the same thing for the other parts, your RY. So RY, summation of forces Y. Starting with the 500, it's upward, therefore positive 500. This is Y component, so we need the vertical, so times 3 over hypotenuse square root of 18. And then 361 is downward, therefore negative 361 times, this is Y component, so vertical, so times 2 over hypotenuse 13. Please solve. What's the answer? Greg Geiser and Lauren. So the Lacrosse trio. One five three point 31. Once again, store. Okay, now I have Rx and Ry. Next step is to solve for the moment about point O. So let's solve. Summation of moment about O. Let's start with 500. Now, again, we no, mali. Kulang sagot mo. Kailangan 0.31, not 0.3. Okay? 2 decimal places ang sagot. Or when I'm asking questions. Okay. Going back, summation of moment about O. Let's observe this 500-pound force. Okay. If we extend this line of action, we can see that it passes through O. So this is one instance where observing your line of action comes in handy, because now I don't have to solve for this, because I know moment is 0. So I'm going to ignore the 500-pound force, okay? So let's take note. Moment of the 500-pound force about O, O is 0. Okay, just so in case someone's wondering why are we not including that. Okay, so now I'm gonna use 361. So we're gonna use again the x and y components of each. Now let me draw it. So these are the x and y components. Oh, no, I'm gonna place it here instead. Okay. Why? Because the x component of the 361-pound force will pass through O. So I'm gonna ignore the x component. So I'm left with the y component. Rotate y about O. That's clockwise, therefore positive. Y component is 361 times, once again, y component, so vertical 2 over square root of 13, or you can just copy what you wrote earlier. Okay. And then distance. This is your y component. Perpendicular distance is this. Count the boxes. 1, 2, 3, 4, 5. And that is equal to 5 inches times 5. Please compute what's the answer. Mhm. Correct, Rafaela and Andrew. Thailand yung pangalan. Ella, Ella, Thailand. It's 1001.23, not 25. Okay? Saan yun nakuha yung 25? Mali kayo ng tingin. Okay. And like what we did earlier, please store that. By the way, unit of this is pounds. Pounds. Moment is pound per square inch. Sorry, pound inch. So don't need to solve for that. All our units are uniform. Okay. Now it's time to solve for your Ix and Iy. Let's start with Iy. Okay, once again, the process to solve for Iy is take moment about O using Rx and Ry. Okay. So using component here of R resultant R, Rx passes through Iy, so ignoring that, so I'm left with Ry. Okay. So summation of moment about O is R, summation of forces times distance. Okay. This is our answer to summation of moment about O, right? So summation of moment about O equals. Okay. Now we're using the resultant. This is solving for MO using components of individual forces. Now we're using the resultant. Okay, once again, Rx passes through over left with Ry. Rotate Ry about O, that's clockwise, therefore positive Ry. Perpendicular distance of Ry to O is Ix. That's Ix. Considering MO is 1001.23, Ry is 153, please compute what's Ix. Remember, you stored those values, so it should be easier to solve for. Mhm. Oh, okay. 6.53, correct? Who got it first? Correct, Zaira? May points ka na ba? Nope. Okay, correct, Zaira. And then Michelle, correct. And then Simone. Okay. 6.53. And then what's our unit? So our unit was pounds and then inch for distance. This is distance, therefore our unit should be inch or inches. Do the same thing to solve for Ry. Okay, but now instead of taking component here, we take component here. So taking component here, Ry passes through point O. Ignoring that, we're left with Rx positive since clockwise. And then perpendicular distance of Rx to point O is Iy, so times Iy. Considering MO again is 1000, 1 Rx is 653, please solve for Iy. Correct, it's 1.53. Correct, Andrew. Thailand. Oh. Michelle, correct. Zaira, correct. 2 points na kayo. And then correct, Kenneth De La Cruz. Once again, wait for me to ask. So the answer is 1.53 inches. Okay? So that is the answer to number 4. Okay? Any questions number 4? Please answer in the chat. How about the others? Please answer as well. Any questions? Okay, thank you. No questions. Let's move on to number 5. Okay, number 5. And I think this is the last question for a moment. In the figure, find the y coordinate of point A so that the 361-pound force will have a clockwise moment of 400 foot-pound about O. Also determine the x and y intercepts of the line of action of the force. Okay, first of all, I need to know the y coordinate, so this YA. And then I need to know the x and y components of your force F. Okay, so this is a kind of reverse engineering. Since we're already given moment, now what we're looking for is a distance. So to solve for that, okay, first things first, YA is pretty easy to solve for. Okay, so we'll just use the equation. Summation of moment about O is equal to summation of FD. Summation of moment about O is given. Actually, let's write the given first. Clockwise moment is 400 foot-pound. So given given. Okay, So this is 400 foot-pound. Make sure your units are consistent. Okay, all of our units are foot and pound as well. So all of them are consistent, no need to convert. So 400 equals 4 times distance, perpendicular distance. Once again, TD is to look for, and also we're looking for Y8. So I need to place my component wherein it's going to use Y8. So that position would be over here, right? Because Fx now has a perpendicular distance of Y8 to point O. Okay. So using Varnum's theorem, let's start with Fx. Rotate Fx about point O. That is clockwise, so positive Fx. Perpendicular distance, once again, is equal to this, which is Y8. Fx times Y8, which is what we're looking for. And then move on to Fy. Rotate Fy about O. That is counterclockwise, so negative Fy. Perpendicular distance is this, which is equal to 2 feet. 2 times 2. Next, create equations for Fx and Fy. Okay. So it's not obvious in the drawing. But if you move this arrow or this portion of your force here, okay, as you can see, they're parallel, right? This right triangle has a base 3 and height 50. Okay? So this force is just moved a bit, so it's not that obvious. But once again, if you try to move it a bit upward to this point, you'll see that its base is 3, its height is 2. And then getting its hypotenuse, that's once again square root of 13. Okay, so Fx is just F, which is 361, times the horizontal, so that's 3 over square root of 13, minus Fy, once again, that's 361 times the vertical, 2 times Ya, minus 361 times 2 over square root of 13, then times 2. From this, please solve what's Ya. Yes, it's 2.67. Correct, Paulo and Kenneth. Aldobe and the law. Perfect. Okay, it's 2.67. Don't forget the unit. Our unit is in feet. Okay, so that's YA. Next, what's the other question? Determine the x and y intercepts, not components. Okay, so x and y intercepts on the line of action of the force. So x and y intercepts. Let's extend this once again. And then let's see if I extend this where it would hit. Okay, so therefore, this is my y component, right? And then this is my x component. So we're gonna do what the same thing we did earlier. Wherein we're gonna place the forces along these points so that if we take moment about O, we're gonna use IY and IX. Let's do that. So I'm gonna put FX and FY here. Let's use this. FX, FY. Same thing, FX, FY. Alright. And then we're gonna use moment about O using those two components. Let's begin. Let's start once again here. Okay. Summation of moment about O, once again, is summation of forces times distance. Solve for moment about O, that's already given. Actually, that's 400. And then instead of using component here, we're now going to use component here. So Fx passes through O. So ignoring that, we're left with Fy. So times Fy, which is, we solved for that already, 361 times 2 over square root of 13. Rotate that about O, that's clockwise, so positive 361 times 2 over square root of 13. And then perpendicular distance of Fy to O is Ix. So times Ix. Please solve what's Ix. Correct, it's 2. Correct, Eman, Antones, and Joaquin. So it's Antones and Ilustre. It's 1.997 or 2. So 2. Unit, feet. Right. And then do the same thing for IY. So summation of N about O. Summation of force times distance. This is 400. This is, okay. Now taking component at this position. Fy passes through O. So once again, ignoring that, I'm left with Fx. Rotating that, that's clockwise. So positive Fx. Fx is this, right? So 361 times 3 over square root of 13, and then perpendicular distance of Fx to point O is Iy. So times Iy, please solve what's Iy. Correct, Paulo and Nicolas. So Baldove and Buena. It's 1.33. 1.33. Unit feet. Those are our answers for number 5. Any questions for number 5? Please answer in the chat. Okay, so that ends our topic for moment of a force.